Next question. Find all points of discontinuity for the function f of x is equal to x power 10 minus 1 if x less than or equal to 1 and x square if x more than 1. Okay. Here you can see the cases. X less than 1 is a one condition. I can classify the cases x less than 1, x equal to 1, you can see x equal to 1 and x more than 1. Okay. For x less than 1, clearly I can observe the function is, for x less than 1, separately I will take it, x power 10 minus 1. Okay, is a polynomial. You know well, every polynomial function is a continuous. Therefore, f of x is continuous for x less than 1. I take this x equal to 1 separately because we studied many times. Whenever x equal to 1 arises, we have to identify LHL and RHL for this. Therefore, for x less than 1, one case polynomial, x more than 1 will we'll go to this calculation, simple simplification, x square again will be a polynomial, so it is also continuous. But x equal to 1, I'll take now for the case x is equal to 1. First identified LHL. LHL is limit function f of x extends to 1 minus, got it? 1 minus. Function correspond to 1 minus. 1 minus means below 1. Below 1 function is x power 10 minus 1 as extends to 1. Once you choose the function corresponding to 1 minus, no need to write again 1 minus, just to write 1. 1 power, you replace x replaced by 1, 1 power 10 minus 1, 1 minus 1, 0. Similarly, RHL means limit f of x extends to 1 plus. All of you know well, RHL extends to 1 plus. Function corresponding to 1 plus is, you can see x more than 1, that is x square extends to 1. Once you choose the function, you just write extends to 1, it is 1. So here itself we arrive LHL is not equal to RHL, isn't it? LHL is not equal to RHL. Therefore, f of x is discontinuous at x is equal to 1. It is continuous for x less than 1 because polynomial, but discontinuous for x is equal to 1. Discontinuous for x is equal to 1. For third case I will move. For x more than 1, function is, for x more than 1, you can see function is x square. So for x more than 1, function is x square, is a polynomial. All of you know well, every polynomial function is continuous. Therefore, f of x is continuous for x more than 1. Let's come to the conclusion. Function continuous for x less than 1, function continuous for x more than 1, but is not continuous at x equal to 1. Therefore, the point of discontinuity, f of x is discontinuous, I can say, or you can conclude the point of discontinuity is, tell me, x is equal to 1 only. In all other case, function is continuous, but at x is equal to 1, function is discontinuous. Okay students, you can take few more examples to solve this kind of problem. Okay, take examples. Find all points of discontinuity for the function f of x is equal to, okay, first take homework, x plus 5 if x less than or equal to 1, x minus 5 if x more than 1. Similarly, second question I have given, third and fourth. Please pause the video and you take homework for these questions. All are of same kind. ನಾವೀಗ ಮೊದಲು ಏನು ಸಾಲ್ವ್ ಮಾಡಿದ್ದೇವೆ ಅದೇ ರೀತಿಯಲ್ಲಿ, ಅಂದರೆ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ ನಾನು ಫಸ್ಟ್ ಹೋಮ್ವರ್ಕ್ ಕ್ವಶನ್ ಬಗ್ಗೆ ಮಾತನಾಡೋಂತಾದರೆ, ಎಕ್ಸ್ ಲೆಸ್ ದೆನ್ 1ಗೆ ಎಕ್ಸ್ ಪ್ಲಸ್ 5 ಪಾಲಿನಾಮಿಯಲ್ ಕಂಟಿನ್ಯೂಸ್, ಎಕ್ಸ್ ಮೋರ್ ದೆನ್ 1ಗೆ ಎಕ್ಸ್ ಮೈನಸ್ 5 ಇಸ್ ಅ ಪಾಲಿನಾಮಿಯಲ್ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್, ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 1ಗೆ ಎಲ್ ಎಚ್ ಎಲ್ ಮತ್ತು ಆರ್ ಎಚ್ ಎಲ್ ಸಪ್ರೇಟಾಗಿ ಫೈಂಡ್ ಮಾಡಿ. ಎಲ್ ಎಚ್ ಎಲ್ ಆ್ಯಂಡ್ ಆರ್ ಎಚ್ ಎಲ್ ಈಕ್ವಲ್ ಆದರೆ ಆ ಪಾಯಿಂಟಲ್ಲೂ ಕಂಟಿನ್ಯೂಸ್ ಆಗುತ್ತೆ, ಈಕ್ವಲ್ ಆಗದೆ ಹೋದರೆ ಕಂಟಿನ್ಯೂಸ್ ಆಗಲ್ಲ, ಅಂದರೆ ಪಾಯಿಂಟ್ ಆಫ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ ಸಿಗುತ್ತೆ. ಓಕೆ, ಯೂಶ್ವಲಿ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 1 ಅಂತೆಲ್ಲ ಪಾಯಿಂಟ್ ಬಂದಾಗ, ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಎ ಇನ್ ಜನರಲ್ ಬಂದಾಗ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ ಅಥವಾ ಕಂಟಿನ್ಯೂಟಿ ನಾವು ಐಡೆಂಟಿಫೈ ಮಾಡೋಕ್ಕಾಗುತ್ತೆ. ಮತ್ತೆಲ್ಲ ರೀಜನ್ಗಳಲ್ಲಿ ಯೂಶ್ವಲಿ ಅದು ಪಾಲಿನಾಮಿಯಲ್ ಸಿಗೋದ್ರಿಂದ ಕಂಟಿನ್ಯೂಸ್ ಆಗುತ್ತೆ. ಬಟ್ ಈಕ್ವಲ್ ಟು ಪಾಯಿಂಟ್ ಬಂದಾಗ ಮಾತ್ರ ದರ್ ಮೇ ಬಿ ಎ ಚಾನ್ಸ್ ಆಫ್ ಗೆಟಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ. ಗೊತ್ತಾಗುತ್ತಲ್ಲ? ದಿಸ್ ಆರ್ ದ ಸಮ್ ಆಫ್ ದ ಹೋಮ್ವರ್ಕ್ ಯು ಹ್ಯಾವ್ ಟು ಟ್ರೈ so that you can easily understand the concept of finding the points of discontinuity.